This is a pretty neat mathematical and artistic object. It's called the stellated dodecahedron, which is a fancy mathematical way of saying a spiky ball. The actual spikiness of it comes from the icosahedron, which is a Platonic solid, meaning it has all the same faces in 3D space. And if I took each face and I pulled it out so it made a spike, it would look like this, because that's what it is. And another cool thing, how it relates back to the Platonic solids, is that if I took each point on it and I connected them with string, cardboard, tape, whatever, we would find that they all make pentagons all around it. And if you did that across, you would end up with another Platonic solid called the dodecahedron, which is just all pentagons interlocked in 3D space. As cool as the Platonic solids are, they don't really relate back to your curriculum. So what we're going to do is relate this back to your curriculum by showing you how to fold it. And a really fun thing to do if you do fold it is investigate the neat property it has, and I would have never known of unless I had folded it, that you can actually collapse the spikes into each other. You can collapse them in different ways to make different polyhedra. So if you go home, if you make this and you enjoy it, you can investigate with that property and play around with it a bit. I find it really fun. But without linear equations, we couldn't actually make the base for each of these individual pieces. So that's what the next video is going to be about. It's going to be showing you how the linear math you've been doing, the linear equations, y equals mx plus b, relates back to this actual artistic shape. You can go home, make it, put on your Christmas tree, or just learn the math, whatever. I hope you enjoy it. I think it's pretty neat. And check out the next video. What if I asked you for something slightly more complex? Something like folding into a third. Well, it's a bit trickier. I mean, I guess you could kind of approximate it by